Welcome you all. In this lecture, we are going to discuss about the three-phase full bridge controlled rectifier with R, RL and RLE load. Three-phase full converter is a fully controlled bridge controlled rectifier using 6 thyristors connected in a form of a full bridge configuration. So this is the figure of a three-phase full bridge controlled rectifier with R, RL and RLE load. All the 6 thyristors are controlled switches which are turned on at a appropriate times by applying suitable gate trigger signals. That is, we will be triggering these thyristors with various triggering angles. The three-phase full converter is excessively used in industrial power applications up to 120 kilowatt output power level. And also this circuit is also known as three-phase full wave bridge controlled rectifier or as 6 pulse controlled converter. Okay, and the upper arm thyristors are numbered as T1, T3 and T5, and lower arms are numbered as T4, T6 and T2 respectively. So at any particular instant, two thyristors will be conducting. Two thyristors will be conducting in any particular instant, and the output obtained here it will be line to line voltage. And here the load I have taken as R, RL and RLE load, and we know that phase voltage VA which is equal to Vm sin omega t, VB which is equal to Vm sin omega t minus 120, and VC will be equal to Vm sin omega t minus 240. So each phase will be having 120 degree phase shift between them, and these are the phase voltage represented here. This red line represent the phase voltage VA or VAO, and this blue line represent the phase voltage VB or VBO, and this green line represent the phase voltage VC or VCO. Okay, and each thyristors will be triggered in a gap of 60 degree, and the conduction sequence will be like this. First T6 and T1 will be conducting, then after that T1 and T2 will be conducting, then after that T2 and T3 will be conducting, then T3 and T4 will be conducting, T4 and T5 will be conducting, and finally T5 and T6 will be conducting. Okay, so we have already told the thyristors we will be triggering at different triggering angle, and in this case, in first case we will be triggering that thyristor at alpha is equal to 0. That triggering angle of the thyristor will be equal to 0 degree. So 0 degree means it will be here only, that is omega t. Omega t will be equal to 30 degree. Okay, when alpha is equal to 0, omega t will be equal to 30 degree. So at 30 degree, you can see here at 30 degree the thyristor T1 is triggered. Okay, the thyristor T1 is triggered at omega t is equal to 30 degree or alpha is equal to 0. Then the next thyristor will be triggered after 60 degree. Okay, here it is written each thyristor will be triggered in a gap of 60 degree. So the next thyristor will be triggered after a gap of 60 degree. So 30 plus 60 means 90. So thyristor T2 will be triggered at 90, and then thyristor T3 will be triggered at 150 degree, and thyristor T4 will be triggered at 210 degree, and thyristor T5 will be triggered at 270 degree, and thyristor T6 will be triggered at 330 degree. So after 330 you can see here a 30 degree is here, 330 to 360. Then after 360 you can see 0 to 30. So this thyristor T6 will be conducting for 30 degree here and again 30 degree here. Okay, so here if I am seeing that is from 30 to 90, which all thyristors will be conducting. T1 is conducting, and before T1 T6 is conducting. So from 30 to 90 degree, T6 and T1 will be conducting. T6 and T1 will be conducting, and from 90 to 150, T2 is conducting, and before T2 T1 is conducting. So T1 and T2 will be conducting, and in this interval 150 to 210, already T3 is triggered at 150 degree, and before that T2 is triggered. So T2 and T3 will be conducting. And now in this interval 210 to 270, already T4 is triggered here, and before that T3 is triggered. So T3 and T4 will be conducting. And in this interval 270 to 330, you can see already T5 is triggered, and before that T4 is triggered. So T4 and T5 will be conducting, and in this interval 330 to 30 degree. So here T6 is triggered here in 330 degree, and before that T5 is triggered. So T5 and T6 will be conducting from 330 to 30 degree. 330 to 30 degree. So these are the various conduction sequence here. So first I will be analyzing the output waveform when alpha is equal to 0. So the thyristor T1 is triggered at alpha is equal to 0, or omega t is equal to 30 degree. So here which all thyristors will be conducting? So already T6 is conducting here, and here thyristor T1 also triggered. So the thyristors T6 and T1 will be conducting when omega t is equal to 30 degree or alpha is equal to 0 degree. So T6 and T1 conducting means T6 is here and T1 is here. It is connected to line A and line B. It is connected to line A and line B. So the equivalent circuit, the all other thyristors will be reverse bias. So equivalent circuit will be like this between terminal A and terminal B. So the output voltage will be getting VAB. VAB we can write it as VA minus VB. We all know that VA means Vm sin omega t. So substituting omega t is equal to 30 degree, we will be getting Vm sin 30 VA minus VB means Vm sin 30 minus 120. VB is here, omega t minus 120. So Vm sin 30 minus 120. Solving this, we will be getting V0 will be equal to 1.5 Vm, or V0 by Vm is equal to 1.5. So that point I am representing here 1.5 Vm. Okay. Now when alpha is equal to 0, we have already got when omega t is equal to 30 degree. Now omega t is equal to 60 degree. In omega t is equal to 60 degree also, here also you can see which all thyristor will be conducting. T6 and T1 will be conducting. T6 and T1 will be conducting. So T6 is connected to line B and T1 is connected to line A. So we will be getting output voltage VAB. VAB minus VA minus VB. VA means Vm sin omega t. So Vm sin 60, VB means Vm sin omega t minus 120. So Vm sin 60 minus 120 we will be getting. So Vm sin minus 60. So solving we will be getting V0 by Vm, which is equal to root 3, or V0 is equal to root 3 Vm. So that point also I am representing here. Now when omega t is equal to 90, that is when alpha is equal to 0 and omega t is equal to 90 degree, you can see here 90 degree means what will be happening here, the which all thyristors will be conducting. T2 is conducting and already T1 is conducting. So T1 and T2 will be conducting when omega t is equal to 90 degree. So T1 is here and T2 is here. So the line A and line C will be conducting. So output voltage will be equal to VAC, which will be equal to VA minus VC. So solving that, we will be getting V0 is equal to 1.5 Vm. So that point also I am representing here. So I will be getting waveform like this. Okay. Now the same sequence will be repeating that is, we will be getting waveform like this from 1.5 Vm to root 3 Vm, then from root 3 Vm to 1.5 Vm, then this cycle will be repeating. And you can see here T6 and T1 is conducting, here T1 and T2 is conducting, here T2 and T3 is conducting, here T3 and T4 is conducting, here T4 and T5 is conducting, and from here T5 and T6 is conducting, here also T5 and T6 will be conducting. And each thyristor conduct for 120 degree. You can see here thyristor T1 if you are taking, T1 is conducting here and T1 is conducting here. So this total duration 30 to 150. 30 to 150 means 120 degree a thyristor is conducting. And the source current will be getting for 240 degrees. So consider line A. Line A, if you are considering, in line A you can see two thyristors are there, T1 and T4. You can see T1 is conducting here and T1 is in upper leg, and here also T1 is conducting. So we will be getting a source current positive, that is from 30 to 150 degree. And you can see here the lower arm diode T4 is conducting from here to here, okay, means 210 to 330. So it is a lower arm diode, so the supply current will be in opposite direction, so it will be like this, okay. So here we will be getting source current in opposite direction, and you can see here also 120 degree it is conducting, and here also 120 degree it is conducting. So totally it will be conducting for 240 degrees. Source current will be conducting for 240 degrees, and the output we are obtained here is a line to line voltage that we have already told. Now we have discussed when alpha is equal to 0, that is triggering angle when is equal to 0. Now we will be discussing when alpha is equal to 30 degree. So this is our reference point. From the 30 degree taken means omega t will be equal to 60 or alpha equal to 30 degree. Okay, alpha is equal to 30 degree or omega t will be equal to 60. So when omega t is equal to 60, you can see here thyristor T1 is triggered here, and after 60 degree thyristor T2 will be triggered, and again after 60 degree T3, then T4, then T5, then T6 will be triggered. So when omega t is equal to 60 degree, you can see here which all thyristors will be turned on here. Already T6 is on and now T1 is triggered. So T6 and T1 will be conducting when omega t is equal to 60 degree. So T6 is in line B and T1 is in line A. So I will be getting output voltage VAB, which is equal to VA minus VB. So substituting in this equation, VA means Vm sin omega t and VB means Vm sin omega t minus 120. So substituting when omega t is equal to 60, we will be getting V out is equal to root 3 Vm. So that point I have plotted here. Now when omega t is equal to 90 degree, omega t is equal to 90 degree also, you can see here which all thyristor is conducting here, T1 and T6 is conducting. So T1 and T6 is conducting, and here also T1 and T6 means line A and line B is conducting. So output voltage will be equal to VAB, which is equal to VA minus VB. So substituting the values of VA and VB when omega t is equal to 90 degree, we will be getting output voltage which is equal to 1.5 Vm, 1.5 Vm. So that also I have marked here 1.5 Vm when omega t is equal to 90. So next case is when omega t is equal to 120 minus. So here two cases will be taking, one will be 120 minus, that is before 120 degree, and one will be 120 plus, that is just after 120 degree. So here just before 120 degree means somewhere here, right? So here which all thyristors will be conducting? T6 and T1 will be conducting. So just after 120 degree means which all thyristor will be conducting? T1 and T2 will be conducting just after 120 degree means. So just before 120 degree means 120 minus. So omega t when is equal to 120 minus, T6 and T1 will be conducting. So T6 and T1 means line A and line B will be conducting. So output voltage will be equal to VAB, which is equal to VA minus VB. So substituting the values of V and VB, and when omega t is equal to 120 minus, or omega t when we are putting as 120 degree, we will be getting output voltage which is equal to root 3 by 2 Vm, root 3 by 2 Vm. That point also I have marked here. Okay, so I will be getting plot like this. Now 120 plus I am taking, 120 plus if I am taking means which all thyristors will be conducting? T1 and T2, T1 and T2 will be conducting, right? T1 and T2 will be conducting. T1 and T2 means T1 is in line A and T2 is in line C. So we will be getting output voltage which is equal to VAC, that is VA minus VC. So substituting that, VA means Vm sin omega t and Vc means Vm sin omega t minus 240. So substituting when omega t is equal to 120 degree, we will be getting V out is equal to root 3 Vm. So that point also I have marked here. So I am plotting the wave. So I will be getting waveform like this. So this same pattern will be repeating again and again. Same pattern will be repeating, and we will be getting output waveform like this. Okay, like this we will be getting output waveform, and output waveform is a line to line voltage, and you can see the output voltage is varying from root 3 by 2 Vm to root 3 Vm, root 3 by 2 Vm to root 3 Vm. Output voltage is varying, and we are getting line to line voltage as output. Okay, so we have discussed when alpha is equal to 30 degree also. Now next case, when alpha is equal to 60 degree. So when alpha is equal to 60 degree, omega t will be equal to 60 plus 30, that will be equal to 90. Okay, omega t will be alpha plus 30, right? So alpha is 60 degree plus 30 degree means 90, omega t will be 90 degree. So when omega t is equal to 90 degree, thyristor T1 will be triggered, then after 60 degree T2, then T3, then T4, then T5, and then T6. Okay, so when omega t is equal to 90 degree and thyristor T1 is triggered, you can see which all thyristor will be conducting there. Already T1 is triggered, and before that T6 is triggered. So T6 and T1 will be conducting there. So T6 and T1 means line V and VA and VAB will be conducting. So the output voltage will be equal to VAB, that we can write VA minus VB. So substituting in this equation, when omega t is equal to 90 degree, we will be getting output voltage which is equal to 1.5 Vm. Output voltage I am getting as 1.5 Vm. Okay, now when omega t is equal to 120 degree, when omega t is equal to 120 degree also, you can see here the thyristor T1 and T6 is conducting. So T6 and T1 is conducting, and T6 means line B is conducting, T1 means line A is conducting. So we will be getting output voltage VAB, that is VA minus VB. Substituting the omega t is equal to 120 in this equation, we will be getting V output is equal to root 3 by 2 Vm. Okay, root 3 by 2 Vm. That point also I have marked here. And now when omega t is equal to 150 minus, 150 minus means just before 150. Okay, so just before 150, you can see here T1 is conducting, and before that T6 is triggered. So T6 and T1 will be conducting. Okay, so T6 and T1 conducting means line A and line B will be conducting. So output voltage will be equal to VAB, which is equal to VA minus VB. So substituting the value omega t is equal to 150 in this equation, we will be getting V output is equal to 0. We will be getting V output equal to 0. So I will be getting plot like this. Plot like this I am getting. So when omega t is equal to 150 plus, you can see here when 150 plus means somewhere here. So at that time T2 is triggered and before that T1 is triggered. So T1 and T2 will be conducting. Okay. So at omega t is equal to 150 plus T1 and T2 will be conducting. T1 and T2 means line A and line C will be conducting, which means output voltage is equal to VAC. VAC means VA minus VC. So substituting the values, we will be getting V output is equal to 1.5 Vm. So we will be getting plot like this, and this will be repeating, and we will be getting output plot like this. Okay. So the output voltage will be varying from 0 to 1.5 Vm here, and you can see here when alpha is equal to 30 degree, 0 degree and 60 degree, the output waveform is continuous. Whether it is R load, RL load or RLE load, the output waveform is continuous. Okay. And now when alpha is equal to 90 degree. Okay. So when alpha is equal to 90 degree, you can see here the thyristor T1 is triggered at 120 degree. Alpha is equal to 90 degree means omega t will be equal to alpha plus 30. So alpha is 90 degree. So omega t will be 90 plus 30, which will be equal to 120 degree. So thyristor T1 is triggered at 120 degree. Then after 60 degree, thyristor T2 is triggered. Then T3, T4, T5 and T6 is triggered. Okay. So at omega t is equal to 120 degree or alpha is equal to 90 degree, you can see here the thyristors T6 and T1 will be conducting. Thyristor T6 and T1 will be conducting. So the line A and line B will be conducting. So we'll be getting output voltage VAB, which is equal to VA minus VB. Substituting omega t is equal to 120 in this equation, we will be getting output voltage which is equal to root 3 by 2 Vm, and that I have marked here. Okay. Now when omega t is equal to 150 degree, you can see here when omega t is equal to 150 degree, which thyristors will be conducting? T6 and T1 will be conducting. So T6 and T1 means line A and line B will be conducting. So we will be getting output voltage VC0 is equal to VAB. So that is VA minus VB. So substituting in this equation, we will be getting output voltage is equal to 0. Output voltage is equal to 0. And now you can see here, so from 150 to 180 degree, there is no thyristor triggering. So the output voltage will be remaining at 0. The output voltage will be remaining at 0 because there is no thyristor triggering from 150 degree to 180 degree. Okay. And till now we have discussed for R load or RL load or RLE load. From here some change is going to happen. Now I am going to discuss only for R load. Okay, only for R load. So if it is an R load, so from 150 degree to 180 degree, okay, 150 degree to 180 degree, there is no thyristor triggering. So what will be happening? The output voltage will be remaining at 0. Output voltage will be remaining at 0. That is from 120 degree we will be having root 3 by 2 Vm, and voltage, output voltage will be reducing and it will be coming to 0 at 150 degree, and from 150 degree to 180 degree there will be no conduction. Okay. So after 180 degree, what will be happening? T1 and T2 will be conducting. T1 and T2 conducting means this line A and line C. Line A and line C is conducting means output voltage will be equal to VAC, which is equal to VA minus VC. So substituting in this equation, when omega t is equal to 180 degree, we will be getting output voltage as root 3 by 2 Vm, root 3 by 2 Vm. So we will be getting output voltage like this. So and this cycle will be repeating, and you can see the plot for R load. Plot for R load will be like this. Okay. So we can see here when alpha is 90 degree or alpha is greater than 60 degree, we are getting discontinuous output in the case of R load. In the case of R load only, I am saying that previous case we have discussed for R load, RL load and RLE load. Now I am particularly discussing for R load. So in the case of R load, when alpha is greater than 60 degree or alpha is equal to 90 degree, we are getting discontinuous output for R load. You can see here from 30 to 60 the output is discontinuous, from 90 to 120 output is discontinuous, and so on. So the output voltage is discontinuous for R load and it is varying from 0 to root 3 by 2 Vm. 0 to root 3 by 2 Vm. Okay. So this is for R load. Now coming for RL or RLE load. So if you are discussing for RL or RLE load, what will be happening? So I0 will be continuous in the case of RL load or RLE load. I0 is continuous in the case of RL or RLE load. So what will be happening? So as I0 is continuous, the output will be following the supply voltages as long as I0 is more than holding current of the thyristor. That is, here thyristor T1 and T6 is triggered now. So after 150, previously in the case of R load, we are getting zero output, but zero output because thyristor T1 and T6 is turned off here since the load is R. But here we are using RL or RLE load, so the I0 output current will be continuous in the case of RL or RLE load. So the current value will be higher and that current value will be higher than the holding current of the thyristor. So even the supply is reversed, the output voltage will be following the supply voltage and the thyristor T1 and T6 will not be turned on at that time. So it will be conducting and we will be getting output like this dotted line in the negative direction. In the negative direction we will be getting output voltage. So for RL or RLE load, when alpha greater than 60 degree or alpha is equal to 90 degree, output will be varying from minus root 3 by 2 Vm to root 3 by 2 Vm, and the output will be continuous for RL and RLE load. Okay. In the case of R load, the output is discontinuous and it is varying from 0 to root 3 by 2. But in the case of RL or RLE load, when alpha is equal to 90 or alpha is equal to greater than 60 degree, the output is varying from minus root 3 by 2 to minus root 3 by 2 Vm to plus root 3 by 2 Vm, and the output voltage is continuous. Okay. And now we are writing the expression for V0 average when alpha is less than or equal to 60 degree. That is for any R load or RLE or RL or RLE load. So the output voltage average output voltage when alpha is less than 60 degree. So a plot is shown here when alpha is less than alpha is equal to 60 degree, and here you can see the output voltage means period will be 30 to 90. 30 to 90 means 60 degree. So 1 by 2 pi by 6, 2 pi by 6 means 60 degree. Variation of omega t means I have already told alpha plus 30 degree, right? Alpha plus 30 degree. So the limit will be alpha plus 30 degree and it is conducting for 60 degree, right? 60 degree means 30 plus 60 means 90 degree. So the limit will be 30 plus alpha to 90 plus alpha VAB of t d omega t. This VAB of t I can write it as VML sin omega t plus 30. Okay, VML means maximum line voltage into sin omega t plus 30, because I am starting from here, right? So omega plus t plus 30. Okay, omega t will be varying here, and from 30 reference point I have taken 30 where alpha is equal to 0. So VAB, which is equal to VML sin omega t plus 30. If I am representing in vector form, this is VA, this is VB, and this is VC. Each will be having 120 degree phase shift between each other, and this dotted line will be minus VB. So we know that VAB is equal to VA minus VB. So it will be somewhere like here, okay, with angle 30 degree. Okay, so substituting VAB is equal to VML sin omega t plus 30 in this equation, we will be getting average output voltage, which is equal to 6 divided by 2 pi 30 plus alpha to 90 plus alpha VML sin omega t plus 30 d omega t, and solving we will be getting average output voltage when alpha less than or equal to 60 degree, which is equal to 3 VML by pi cos alpha. Solving we will be getting root 3 root 2 VL. VL means line voltage. 3 root 2 VL divided by pi into cos alpha, which will be 2 times the average output voltage of half wave controlled rectifier. So in full wave controlled rectifier, the average output voltage will be 2 times the average output voltage of the half wave controlled rectifier, and the average output voltage which will be equal to 3 root 2 VL divided by into cos alpha, where alpha is the triggering angle and VL is the line voltage. Okay. Now when alpha greater than 60 degree for R load, V0 average I can write it as 1 divided by 2 pi by 6, and conduction you can see here, it will be 30 plus alpha to, means limit will be from 30 plus alpha to up to where it is conducting 150 degree, right? 30 plus alpha to 150 degree VML sin omega t plus 30 d omega t. So V0 average I will be getting VML by pi into 1 plus cos 60 plus alpha. This will be the average output voltage expression for R load when alpha greater than 60 degree. And you can see here a thyristor conducts for 120 degree. You can see here thyristor T1 and T6 is conducting here, and here T2 and T1 is conducting here. So T1 is conducting from 120 degree to 240 degree. So 240 minus 120 means 120 degree. So a thyristor will be conducting for 120 degree. So the average thyristor current, average thyristor current will be I0 into 120 by 360, which means 1 divided by 3. So average thyristor current is equal to I0 by 3, and RMS thyristor current will be I0 into 120 root of 120 divided by 360, which will be equal to I0 by root 3, which will be equal to I0 by root 3, and one supply will be conducting for 240 degree. You can see here the one supply means, if I am taking this line A means thyristor T1 and thyristor T4 is there. So here thyristor T1, where it is conducting, thyristor T1 is conducting here and here. So from 120 to 240, that is 120 degree thyristor T1 is conducting, and thyristor T4 is conducting from where to where? Here T4, T3 is conducting, T4 and T5 is conducting. So this thyristor T4 is conducting from 300 degree to 60 degree, that is again 120 degree. So a supply total it will be conducting for 120 plus 120, that is 240 degree. So the average supply current will be equal to 0, because when T1 is conducting we will be getting a positive current, that is from 120 to 240, 120 to 240, and when T4 is conducting we are getting a opposite current, that is from 300 to 60 degree. So this both will be getting cancelled each other and will be getting average supply current which will be equal to 0, and RMS current will be which is equal to I0 into 2 root of 240 divided by 360, which will be equal to I0 into root 2 by 3. So that will be the RMS supply current. And the circuit turn of time when alpha less than 60 degree will be equal to 240 minus alpha by omega, and circuit turn of time for alpha greater than 60 degree which will be equal to 180 minus alpha divided by omega. So till now we have discussed full wave bridge controlled rectifier with R, RL and RLE load. So up to alpha is equal to 60 degree, the case will be same for R load, RL load and RLE load. When alpha is greater than 60 degree, we are getting discontinuous output waveform for R load and continuous output waveform for RL and RLE load. So this is all about three-phase controlled bridge rectifier with R load, RL load and RLE load. Thank you.